All right, I'm going to show you how to do this with graphing, and I'm also going to show you how to do this with algebra, because today's homework is about solving inequalities by both graphing and by algebra. All right, what's the difference between this and just equals 2? Like if this had just said equals 2, then I would find two answers, and they would be my two answers. This has a range of things. Think about this for just a minute. What's underneath here, do you get there would be some things that would be less than 2? But not an unlimited number of things can be less than 2. Because why? Because we can't go below 0. Because why? Because an absolute value, it changes that and makes anything that's negative back into positive again. All right, so we need what's underneath here to be less than 2. So give me an example. You could come out with an answer like what and be okay? If it came out with 1, or if it came out with 0. But can this absolute value come out to like -4? No, because the absolute values can't come out negative. All right, so now how do you solve it? I guess I'm going to give you the algebra way first. And so in your notes where you made the smiley face, be ready to try this with me. Write this problem down if you haven't already. And now we're going to act just like we already got the clump alone here. All right, we've already got this thing alone. There's no like +8 here. That would mess it all up. We have to get rid of that stuff first. So the clump is alone. And now I need to just simply solve this like it's a normal equation and break it into two parts. X minus 3 is equal to 2. Notice I changed that to an equal. And I have x minus 3 is equal to -2. Now you might be saying, but wait a minute, Mr. Server, you can't have absolute values be negatives. But remember, what's in here, I can make what's in here be negative. It's okay, because it'll just make it absolute value of it, and it'll be all right. All right, now, solve those two equations, and you'll get an answer, but you won't be done. In the past, you would have just been done. You add 3 to both sides, x equals 5. We add 3 to both sides, x equals 1. Now, why aren't you done? Because there's a range of answers. A bunch of things will work. The things that are between, pull it together, between what? Between 1 and 5. Yeah. All right, so to finish this problem off, you need a number line. And you need to put the important two numbers on the number line. Obviously, the 1 and the 5 are the important numbers. Here's a 1, here's a 5. And then you circle them because they're important numbers. And now, do you just assume that the numbers between 1 and 5 work? You better not. You better test them. Why? Because sometimes what happens is only the numbers above 5 work. Everything else might crash your function. Or sometimes only the numbers between 1 and 5 work. Sometimes the numbers between 1 and 5 work and the numbers above 5 work. You know what I'm saying? We don't know which little zones work and which ones do and which ones don't work. We don't know. So here's what we do. We test intervals. Now this one I'm teaching you right here, we're going to use for probably 7 different times on homework and tests over the next few weeks here. This comes up a lot, not incredibly much, but you have to know this process pretty well for Precalc. It's called testing intervals. This is a little interval. This is an interval, and this is an interval. And maybe one of those intervals works, maybe 2 of them work, maybe all 3 of them work. We got to figure out which ones work. So how do we do it? We just take a number that's in that interval and test it. And if that number works, then everything in that interval will work. So what is a number that's in this interval between 1 and 5? Give me any number. 4, 2, whatever. Okay, where I put the mark is probably closer to 2. All right, so I'm going to say 2. I'm going to test 2. How do I test 2? I go back to the original problem. I stick in a 2, and I see if what happens is that it works or if what happens is that it fails. All right, does 2 minus 3 equal -1, or am I losing my mind? It's -1. And then you take the absolute value of that, and that would be what? 1. Is 1 truly less than 2? So would you agree that 2 worked? And since 2 worked, everything in that interval will work. I get the feeling some of you are like doing your chemistry right now. Don't do that. Be with me. I don't want to have to come out there. All right, now I'm going to go to the next interval I'm going to check. I'm going to check 6, something just past 5, 6. I want to put a 6 right here and see if it works. 6 minus 3 is what? Absolute value of 3 is? 3 is 3 less than 2. No. What did I just figure out? That does not work, and I'd like you to put an X over that area. Jackson, tell me a number I can check that's somewhere in this zone. 0. That's one of my favorite numbers to check. It makes things cancel sometimes. So I'm going to check 0, see if it works. I'll put a 0 right here. 0 minus 3 is negative 3. Absolute value of that is what? 3. Is 3 less than 2? No, it didn't work. So it turns out this time it's between 1 and 5. You can't just assume that, though. That sometimes that's the way it goes. Sometimes it's different. You can't just assume it's going to be between the two numbers you found. All right, now one more thing. How about 1 itself? Does the number 1 work or not? Watch what happens. If I put in a 1 right here, I will get absolute value of negative 2, which is 2. And it's 2 is less than 2. Is that true? No. What would have made it true if the sign had been or equals? If the sign had been or equals like this, then it would have been true. Do you get that this is one of those times where it can't be 2, so we have to have an empty spot around our 1 and our 5? And if this had had an or equal to, we'd have been able to fill in this one and fill in that one. Now some of you will catch what I just said there, where if it has an or equal to, you can fill them in. And others of you will not be able to handle that, and you'll just have to test it each time. Test the 1, see if it works. Doesn't work, empty spot. Test the 5, see if it works. Turns out it comes out to 2 is less than 2. Doesn't work, empty spot. But the smarter of you are going to catch on to this pattern that, oh, if it's a less than sign, these are empty. If it's a less than or equal sign, these are filled in. Okay? Try to be one of the smarter of the group, but it will work to test every spot. Test this spot and test that spot along with all the other spots. It's just slow. All right. How could I have done that with a calculator? Let's actually graph them. So let's go back to this here and graph for me the absolute value of x minus 3. In case you've forgotten where absolute value is the one, I usually use the catalog button to get to it. The catalog button is right above the 0. All right, so take this thing, pop it in your calculator as 2 equations. y1 equals this and y2 equals that. It doesn't really have to be that. It could be, you could have y2 be the other one. It can be reversed, but okay. So I'm going to put in absolute value of, and that's again, I use the catalog button to get there. And absolute value is the top one. Absolute value of x minus 3. And then the other thing I'm graphing is a 2, just a 2. You don't use a less than sign. We just graph those 2 things. And you see where they cross, right? So I'm going to hit graph. Oh, my zoom is really weird. I'm going to go zoom 6 and see if that fixes it. There we go. Now, take a guess. What part of my equation works? The one underneath the line. The part that's less than 2. So I find the 2 line, which is this line right here, and whatever's less than that means underneath that. So that little part of the graph right there is the part that we need. That's the answer. Well, where is that? That's between, oh, rats, hold on. How do I do this? There we go. That's between 1 and 5. Do you get that? I personally would rather just do it algebraically, but it depends. Now, what are those important spots? Those are intersection points, right? Can I get the 1 and the 5 from second calculated intersect? You bet I can. I can go second calculate, intersect, enter, enter, enter will get me one of my 2 points. There we go, 1, comma 2. So I know it's at 1. And I go second, calculate, intersect again, except this time do it more carefully. Enter, enter, and then on the third time, guess, you move over to guess where about it intersects. I guess they intersect about there, 4.89 or whatever, and it's actually 5. There we go. Okay, do you see I found the 2 important spots, 1 and 2 by that? And I have to know that it's underneath the line. There is one more cool thing I can do that helps you get this answer. Go back to your y equals screen. Go down to y3. And we can tell the calculator one more thing. I'm going to pause while I get this ready. Okay, so I'm starting to enter this. y1 is less than, and since I didn't show on the video how to do this one, I'm going to delete that and try that again for people. You go on the catalog, and the catalog is right above the 0 button. y1 is, now I want less than, and it's arrow, you got to arrow up a ridiculous number of times to find the less than from the bottom of the catalog. That's why I'm arrowing coming up from the bottom on it. And, oh, I went past it there. Do you see how there's less than and equal to also there? But we don't want that one right now, but just see for future reference, they do have less than and less than or equal to or greater than. Okay, so there's a less than sign. y1 is less than, and of course I want y2. It's under bars, and y bars, and it's a function. And y2 go down 1, and there it is. y1's less than y2. Now what does it do on the graph when I hit graph? All it does is draws in that little line for you to say it works from there to there. You get that extra little line? Okay. Yes, sir? I did. You didn't get the line? Okay, go back to your y equals screen. Read me what it says on y3. Yeah, y1. Less than? Is it the pointy end on the left? Okay, good. Now, how about this? Go to your y equals screen and make sure that your y1 and your y2 are identical to mine. All right. Go to your graph and hit zoom 6. Did that fix it? All right, good. I just went through the common things to fix it. So, all right, cool. So, moral of the story. Of course, when the graph gets a lot more complicated, you can still graph it. You just type in more complicated thing. But if it's a less than symbol, you use this, of course. And of course, we're going to change some of these to greater than. Sometimes it'll be less than or equal to. Okay. All right, so let's just do one more example problem, and I think you're going to be good for the whole lesson. All right. We're going to do this one first with algebra, and then we're going to solve it with the calculator. All right. So here's one. Pausing for a second. I decided I'm going to do problem number 13 off the worksheet. So everybody needs to find the worksheet, which is called P7-1. Thank you very much. And we're doing problem 13, which is absolute value of 4 minus 3x is, no, wait, minus 2 is less than 4. All right, you remember that dumb saying, get the clump alone? The clump is not alone, so we need to get the clump alone. So we add 4 to both sides. Now, 4 minus 3x is less than 4 plus 4 is 8. Do you get that I would not have had to do that if I was graphing it? You can just always graph the original one. You can just graph what you see. I added 4 to both sides. That's why I had people looking up at the board going, what the heck? Plus 2, sorry. 4 plus 2 is 6, yes. Okay. Now, hopefully there's not as many confused looks out there. Good. So now what? Break it into 2 parts. Got 2 equations to solve. 4 minus 3x is equal to 6, and 4 minus 3x is equal to negative 6. And remember that all we're doing is finding the endpoints. These are the important points on your number line. Then you're going to have to test intervals. These things take a while. This is one of those examples of how Precalc gets so much harder than HA. Because in HA, you'd have been done. We'd have never gone to this crazy, like, okay, now you got to not only find the answers, now you got to put them on a number line. Now you got to test each interval. Now you got to be careful with the endpoints and see, should they be filled in circles or empty circles? It's just so much extra stuff. All right, so I'm subtracting 4 from both sides, and I get negative 3x equals 2. And then I divide by negative 3. X equals negative 2/3. Over here, I have minus 4, negative 3x equals negative 10. Then you divide by negative 3, and x equals negative 10 over negative 3, which is positive 10/3. All right. Now you need to know generally which one's smaller and bigger, but you don't have to like figure out exactly where 2/3 is on the number line. You just kind of know, okay, the negative 2/3 is down here somewhere, and the positive 10/3 is up here somewhere. That's all you got to know. Now I'm going to circle both of them because they're important points. Now whether to fill them in or not is a different issue. So tell me, should I fill them in or not? Why? Why should I not? Because it doesn't say or equal to. If this sign had said or equal to at the beginning, we'd have filled them in. So we do not fill them in. Okay, now I got to test intervals and see where it works. This is a painful part. And let me tell you, if you want a good grade, everybody gets to this part. What separates the people that get the A's and the B's from the people who are stuck with C's is the testing the intervals. You might think, oh, it's easy from here. This is where everybody screws up. So be careful when you're testing your intervals. Okay? Now, name a nice thing that's between negative 2/3 and positive 10/3. 0. 0 is in there. That's a very nice, easy thing to test. So I'm going to test 0. Go back up here, put a 0 in. Now I got 4 minus 0, which is 4. Absolute value of 4 is 4. 4 minus 2 is 2. Is 2 really less than 4? It worked. Okay, so now that this is filled in, I can tell you at least, you know how generalizations aren't always true? Like girls are slower than boys. Always true? No. But is there a reason that there's a men's Olympic race and a women's Olympic race? Yeah, because the reality is there's never been a woman that could have beat the man at the sprint at least. Okay? And the Olympics, does that mean every woman is slower than every man? Of course not. Okay, so, but the point is there's reason for generalizations because sometimes they're generally true. Generally, if you shade it in between, the ones on the outside aren't going to work. Generally. Does that mean always? No. So if you're on the test, I would test all 3 of them. If you're on a homework problem, if I shaded in the middle, I'd be done and say it's probably not going to work on the outsides. I'm going to stick with that. It'll save you a ton of time. But like I said, is it always true? And we like to throw in the exceptions on the test, where it like works in the middle and it works up here. I mean, that can happen sometimes. But generally, if you shade in the middle, it won't work on the outside. And of course, the counter example is generally true also. What if it hadn't worked in the middle? Then it probably works on this end and that end. Most times. Not always. Yes? Yep, check any number in between them and see if it works. If it does work, you shade it in and your answer is between this and this. That's a good question. So how do you actually say the answer? Well, you should check these points, but I kind of did before. I don't know if you noticed this. I checked these exact points by asking, will they work or not? And I used this little method. Since it didn't have an equal sign here, if it had had an equal sign, I'd have filled them in. But it did not have an equal sign, so I'm leaving them empty on purpose. Could I check them? If you want to be extra sure, yeah, I could. But it's going to take extra time, and I know the smarter way, which is, since there's not an or equals sign there, these have to be empty. So now my final answer. How do you write the final answer? I haven't even written the final answer. Final answer isn't the number line. You got a guess? Oh, you're close. We use interval notation. Do you remember on the very first day of this class, we taught you how to use brackets and parentheses with a comma? So it's negative 2/3 comma 10/3. And now, should I use brackets or parentheses for these? Parentheses. There's your final answer. That's why we taught you that in the first day of school. It was a kind of an easy concept, and we're going to use it a lot during this part of the unit. So the final answer is the interval between negative 2/3 and 10/3 works. And negative 2/3 doesn't work. That's why there's a parenthesis around it. And positive 10/3 does not work. That's why there's parentheses around it. By working, I mean if I actually stuck 10/3 into this problem, stuck a 10/3 right there, it would not work. It would end up coming out with 4 is less than 4, which would not be true. So that's why the original problem does not have an equals there, and therefore the endpoints do not work. Yes, ma'am? An example of one that works on the outsides. You're going to get some. You're going to get some in your homework. It's not that, different than this problem. It's just when you test the middle, it doesn't work. When you test a number on the outside, like something bigger than 10/3, like 5, any whole number that's bigger than 10/3. If you're not sure exactly how big 10/3 is, go big. Pick like 10, because 10 would be somewhere out here, right? Check 10 and see if it works or not. I can double check 10 just to make sure I didn't screw something up. If I put in a 10, let me make sure that this doesn't really work. Okay, 4 minus 30 would be negative 26. The absolute value of that is 26. Is 26 minus 2 is 24. Is 24 less than 4? No, not even close. So therefore, it doesn't work on the ends. Therefore, it only works in the middle, and therefore the answer is that. Okay, now could you have done this one with a calculator? Yeah. You're just going to graph both sides, see where they cross. And those endpoints, these would have been decimals. The calculator would have said negative 0.6 repeating. And here the calculator would have said 3.3 repeating would be your endpoints. And I'm okay with you using decimals then when you give your answer. But it would have been the same exact thing. Yes?
What do you do if how do you write in the interval notation if it's say it doesn't work in the middle or it works in the middle?
Okay. I gotcha. So let's say it's like this. Here's 5, here's 7, doesn't work here, doesn't work here. You check the number 6, doesn't work there. Then it means it probably works on the outsides, right? And so I think what you're asking is, how would you write this answer then if it worked like out there and out there? The way you write it is you'd say it works between negative infinity and 5, and it works between 7 and infinity. And there's 2 other little important things. You check and make sure you didn't make the mistakes on your parentheses or brackets. Should these be brackets or not? No, because they're empties. Okay? And then if this works and this works, you've got to somehow separate these two, and you can't do it with a comma, or you're going to be implying it's 2 points, something, comma, something. So what you do is you use the little U for a union sign. That's how you say this and this works. You put a U for a union. Yes? But you can't touch infinity. When you're saying bracket, it means you can touch there. If I put a bracket around infinity, I'm saying I can get to and touch infinity, but you can't. No, it just means you can touch at that spot. So this 5, can you tell I cannot work at 5 from my graph because it's got an empty spot? So it can't be 5, so I have a parenthesis. If it was allowed, like if this was darkened in, filled in, that means 5 works in my equation, then I'd have to have a bracket. That would mean that you can touch 5 with this function. 5 works in this function. So our original problems always look, again, like this. That would mean that 5, when you stick it in, actually works. But in this kind of problem that has a less than or a greater than sign without the equals, the endpoints will never work. They'll always be empties. They'll not work. Yes?
So then how would you do it if something was in the middle and it works, but then on the outside?
Okay. So let's say we have 6 and 8, and let's say it works here, and it works all the way in here, and it doesn't work here, and then it works there. I want you guys to give me your guess on how you would write this as 2 intervals. It's got to be 2 things. How would you think you'd write the answer if this was the graph? Take a guess. Got an answer or a question? Okay, just hold that thought a second. I want people to try this. Write this down. Write down what you think it would be. How do you say it works between 6 and 8? Doesn't work at 8. Then it keeps working after 8. You should have said 6 to 8, bracket on the 6, parenthesis on the 8. Raise your hand if you're right so far. Okay, good. Then, how do you say this works and something else works? U for a union symbol. All right, and then how do you finish it? I saw that. We'll be talking later. Okay, I want you to be with me on this, not looking at something else. All right, this last part, how do I go from 8 to infinity? You just write 8 to infinity. And then, can it work at 8? Parenthesis. Can you ever get to or work at infinity? No, because you can never get there, so it's a parenthesis. There you go. Raise your hand if you had it all right. Okay, good. All right. Now, to put this one in the calculator, I do want to do one. I mean, this is problem 13, so it's not going to hurt for us to double check, make sure we did it right. I have a choice now. I can put the original into the calculator, or I can put this one in the calculator. It is a little cleaner, probably a little easier to put into the calculator, so let's do that. Put 4 minus 3x on the first y equals. Put the 6 on the other y equals. And I'm going to come around and look at these, so don't be like doing other homework right now. I want to make sure you know how to graph these. So you put in 4 minus 3x in there. And then a 6 right there. And you can even leave that y1 is less than y2 in there. It's kind of handy. You don't have to retype it every time that way. Now, if they change it to greater than, you'll have to adjust. But remember where those signs are is under the catalog button. All right. Show me that you can make a graph that looks like this. And it's saying that it works right in there. You get how it's, if it had worked on the outside, it would have had little black lines that go like this and none in the middle. That's how it would tell you it's working on the outsides if it was. But this one's working on the inside. And all you'd have to know is, where are those two spots? So I can calculate intersect. Right, let me see your graphs. Make sure you did that right. And that's all I have for the video for today. Hey.